Greetings and welcome to another video. In this one, we will be again working with SimSolid, which is brought to you by Altair. And the folks at True Insight have graciously worked with me to bring you these videos. So moving on to the actual program here, SimSolid. I've used this cart in a couple of other videos, so we will continue to use it. Last time we set up a hydrostatic pressure on this panel here, but the problem is the panel is not connect because I didn't actually put in any welds in particular. So today we are going to put in some spot welds. So what does it look like without the spot welds? Well, let's just show what that displacement looks like. And as you can well imagine, it's pushing this out here. You remove some of those edges. There you go. So now you can see that it's pushing that out just as one would expect. So I'm going to put in some welds right along here in a couple of different ways. So let's go ahead and do that. Now, I'm going to take this study here, this design study, and I'm going to copy it. And it immediately copies it nicely. So I'm going to call this design study 2. I'm going to, I already did the 2 and 4 layer, so rename it example 2 layer. And so next thing we're going to go is go to connection. So weld is obviously a connection, so we're going to go here to create spot welds. And we can do this in a couple of different ways. So these are the defaults. It immediately goes to standalone spots, but we can do an import as well. Thing is, with import, you need to know your coordinates off the bat and put them into a CSV file. You can see a CSV file, and we'll do that in a little bit, but not quite yet. Okay, so we're going to go back to standalone spot and zoom in here, and I want to connect it right here. All right, there we go. So it shows up with the coordinates of that location, which is great. We can change the size right up here. So I'm going to make it a quarter. And it keeps that default throughout. So when you come back, it'll be that same size. Okay, so let's hit it. And one thing we want to do is always, always, always check your connections. So make sure that it got to both this one here. So review part connections. It shows up here as a spot weld. Okay, great. And then check here. And it shows up on this part too. So we know that those two parts are being connected with that weld. Now, very often you're going to want several welds. And you don't want to necessarily just put it in a random spot. You might have it all programmed. If you do have it programmed, then that's the best spot to use the import, and hopefully your locations for your computer controlled welding will be easily imported in. Make sure you use the correct coordinate system and all that. But I'm going to show you a couple other ways of looking at it. So they also allow for this linear pattern. So I'm going to delete this spot weld here. And I'm going to go to create spot weld, spots on a line. So it's a linear pattern. And I want to go have 5 of them. And it's pretty easy to set up. So I'm going to put the center right there and come back out like this, zoom down here, and put the last one down here. So you click on the first spot and the last spot. There it is. And it fills in the other ones for you. There aren't too many settings to allow you for other patterns, but in a pretty straight line, it works out really well. All right. So thing is, though, if you'll notice as I go through spot weld 1, the X is this, the Y is that, the Z is that, and they're not really quite lined up. They're close, but they're not lined up. So what we can do is we can export this into a CSV so that you get an idea of what it's going to look like. I'm not going to show you all of the specific steps because it goes into my directory and you've got your own directories and stuff like that. So, but we'll see how this goes. So I'm going to save all of them. Okay, now that I have these saved into a file like this, notice how it shows up. Does not identify connected parts 1 or 2 or the weld type. It just has those available. We'll look at that later. But it gave us our coordinates here. So uh, if I wanted to make sure that they were all kind of right down in a line, I can change my table here to, let's just say that the first point is exactly where we kind of wanted it, except I wanted it 24 inches up. And I'm going to use, this came in as text, so I'll just retype it 14.227 and 0.819. All right, so then go equals this minus 5 equals this. Okay, so now I've got these. I'm going to do a drag down. And so now I've got all of them exact same Z, X position, and Y goes exactly 5 inches each way. So I'm going to hit save on that. Put that aside. And now I'm going to go back here. I'm going to hit import. Okay, here they come. Now, one thing you got to note is that these numbers here don't perfectly match up to the numbers that I exported because I believe that the actual uh, information that you're going to get here is from like the centroid of that weld. So it's going to be a little bit deeper in. So X and Z aren't going to match exactly, but Y does match exactly. So just pointing that out there too, in case you're wondering what it was doing with the data. All right. So now that we've got that all up and down, you can hit OK. And again, going to check to make sure that it's got the connections on that one and that one. That the spot welds are where we expect them to be. All right, so we went over the different kinds of spot welds that are available. The imported, the standalone, the spots on the line. Problem is, for my particular design, I have these hems that are right here that create 4 layers, not 2 layers. So over here where I put those welds, I only have 2 layers. Here I've got 4 layers, and but the standalone spots can actually do 2, 3, or 4 sheets. Uh, Doing it for the imported or the spots on the line, even though it looks like it can do it when you do the importing, it does not pull in the fact that they have multi layers on them. So you have to do them like this. So if you want to have them in a nice straight line like I did, uh, it's doable, but a little clunky. So I think the best way to do it is just to click right approximately where you want it there. And you'll notice that the coordinates come up here. So I'm going to make this 21.5, which is right in between these two. And then I'm going to make 3 more welds. And I'm going to change all of their X and Z coordinates to this using the tried and true copy and paste. Okay, so going to come back up here to what I thought was the best one. And now I know they're all going to be right in a line. And I wanted them 5 inches apart from each other as well. So And this one's going to be 6.5. All right. So clunky though it may be, looks like I should have what I want. And here they are. 1, 2, 3, 4. So you can see them as you go down the line there. Okay, so I'm going to do that. And then I'm going to, I'll change that to example. So I did both 2-layer and 4-layer on this. And then I'm going to run the analysis. Okay, so I'll be back in about a minute. So we are back here with the results. Check out that displacement. And you can see that our welds held nicely here. And over here, where we didn't have the welds, we have the deflection that we expected. And even a little deflection here, just as one would have expected. Okay, so if we only had the 2-layer spot welds, this is the result we got. And you'll notice that they're held together pretty well right here and not a lot of deflection over here. But if we only had put the 4-layer spot welds in that were over here, we would expect some deflection and opening up with everything else here. And that's exactly what we got. So if we weren't able to do the ones right close to the joint here, then we would have had to settle for the 4-layer spot weld. Okay, so in review, we just went over all the different spot welds, some of the tips and tricks, watching out for how it imports and exports the coordinates, always making sure that you check your connections, and noting that the 4-layer spot weld, or anything beyond 2, is going to require using the standalone method, which may become cumbersome if you have a lot of welds. All right. Well, I hope you enjoyed and got something good out of this demonstration, and that you continue to engineer productively and realistically.